So happy when this is over. This is Unit 7, Lesson 7, using a model from a dataset. First, as a check-in, what is bivariate data? Bivariate data is the data of two variables, and because that makes no sense and is completely useless, it's data on like an XY graph, okay? How to interpret bivariate data using its scatter plot and regression model. There's 4 ways you can interpret bivariate data. There's association, which can be positive, negative, or no association. Positive slopes up, negative slopes down, and no association means it's a random scatter plot. A relationship can be linear or non-linear, so it either makes a straight line or it doesn't. A curved line does not work. Strength is either strong or weak. That has to do with how close to that line all of the dots are. Close to the line means it's strong. Way far out from the line means it's weak. And outliers are when you have a line, the dots are all close to the line, but there's like random 1 or 2 or 3 that's like way out. Those are outliers. Let's look at example 1. Interpret the bivariate data by using its scatter plot and regression model. Describe the association, relationship, strength, and outliers. So, first, the association is positive. You can see this line is positive. The linear relationship increases as you move from left to right. The relationship is linear because the points closely resemble a straight line, or they have a straight line in here. I wouldn't say this closely resembles a straight line, but they do. The strength is strong because the points closely follow a straight line. Sure, if you say so, these ones do, maybe these ones. There is an outlier at approximately 7540. This point is different from all the other points in that it lies outside the pattern of the other points. These ones you can all kind of be like, okay, I can see that being part of the line, not this one. That makes it an outlier. What is a way you could describe the relationship between the temperature outside and lemonade sales? So what would you say is the general trend of this entire graph? Lemonade sales increased as the temperature increased. The outlier could be an error caused by data collection or an entry error, so like human error, they screwed up. The outlier could also be caused by the fact that on the day that this data was collected, there were competitors selling substitute products, such as soft drinks, water, or slushies. This scatter plot represents a positive linear relationship because it increases from left to right. Here's example number 2. Interpret the bivariate data by using its scatter plot and regression model. Describe the association, relationship, strength, and outliers. Association is negative because it's decreasing as you move from left to right. Relationship is linear because the points closely resemble a straight line. The strength is strong because the points closely follow a straight line. They're all really close to this line, and there are no outliers. So how would you describe the relationship between hours spent on social media versus a student's grade in class? The more time spent on social media, the lower the grade a student receives. Here's example 3. Interpret the bivariate data by using its scatter plot and regression model. Describe the association, relationship, strength, and outliers. There is no association, there is no relationship, the strength is weak, and there is no outlier because this is completely random. I could draw a line anywhere I want to through here, and not all of the points are going to be close to that line. No line is going to be accurate. This is random. So no, weak, no. Example 4, interpret the bivariate data by using its scatter plot and regression model. Describe the association, relationship, strength, and outliers. There is no association. You cannot have curved lines, some weird constellation pattern. It has to be a straight line. The relationship is non-linear because the points do not resemble a single straight line. The strength is strong because the points closely follow a curved line. So we can make a pattern out of this. We can draw a little Mr. Constellation here. So the strength is strong, okay? There are no outliers. Analyzing the graph, it appears that the overall happiness is at its highest between 90 and 95% when a person works between 20 and 45 hours per week, or more than 45 hours per week. If a person works less than 20 hours per week or more than 45 hours per week, overall happiness decreases. Okay, so these are our highest points. This is the ideal amount of time to work a week. Here's a check-in. How do you interpret bivariate data using its scatter plot and its regression model? You look at association. Is it positive, negative, or no association? Relationship. Is it linear or nonlinear? Strength. Is it strong or weak? And remember, you can have a nonlinear relationship and a strong strength if it's following a pattern, just not a linear pattern. And outliers. This information you want in your notes. I'm going to put it in mine. Okay, question 1. This one is all your turn. Interpret the bivariate data using its scatter plot and regression model. Describe the association, relationship, strength, and outliers. Pause the video, figure it out, come back. Okay, relationship is either positive, negative, or no association. This one is obviously negative. Relationship is linear or nonlinear. It's linear because it has a straight line. Strength is strong or weak. It's strong. They're all relatively close. And there are 3 outliers. Okay. It says there's only 1 outlier. I guess they consider this one close. This is the outlier. All right. Question number 2. Interpret the bivariate data by using its scatter plot and regression model. Describe the association, relationship, strength, and outliers. Pause it and figure it out. Okay, association is either positive, negative, or no association. It's positive. It's either relationship is either linear or nonlinear, straight line, so it's linear. Strength is strong or weak. It's strong. Outliers, there are 0. Okay, this is at the end of your lesson, and look at that. My graph went away. This data set represents a strong or weak relationship. Okay, remember, it doesn't have to be linear to determine whether it's strong or weak. It only depends on how close the dots are to the line. This one would be strong. They're all relatively close to that line. You don't have a random one. Okay. Practice question 2. Which option best describes the relationship between sweater sales and temperature? Relationship is either linear or nonlinear. This is linear. So sweater sales increase as temperature increases. That would be a positive relationship. Sweater sales decrease as temperatures increase. That would be a negative relationship. For me, it's number 2. It might be shuffled. It might be different on yours. Practice question 3. What type of association is represented by this scatter plot? Association is positive, negative, or no association. This one's no association. This one's completely random. Here's quick check question number 1. Which of the following interprets the most likely cause of the outlier in this scatter plot? So we have on the x-axis temperature in degrees Fahrenheit, and on the y-axis we have quantity of sweaters sold, and we have this one random outlier here that's way above the line for everything else. So the options are: there is a 1-day sale on sweaters on a warm summer day. A sale on sweaters during the winter causes more sales. The least number of sweater sales is on the hottest day of the year, and the greatest number of sweater sales is on the coldest day of the year. So you'll have to look at this and figure it out. There are 2 that are very obviously wrong. So just take your time on this. Don't rush. Here's quick check question 2. Which of the following best describes the relationship this data set represents? Is this linear, negative, no association, or non-linear? Quick check question 3 says which of the following best describes whether the relationship is strong or weak, and why is it that way? So look at this. And then the options they give you are: the relationship is strong because the points model a straight line or curved pattern. The relationship is strong because the points do not model a curved line or straight pattern. The relationship is weak because the points model a straight line or curved pattern. And the relationship is weak because the points do not model a straight line or curved pattern. Next part of the lesson, check in. What is bivariate analysis? A bivariate analysis is used to determine if there is a relationship between the 2 values. Okay, this is correlation. We've done this before. You use GeoGebra for this. Regression is a model or relationship between 2 or more variables that is often determined from data, and it's used most frequently to predict values of one variable when given values of the others. line of best fit is a straight line in which the distance between it and the data is minimized, and it's used to perform regression analysis. All of the lines we've seen so far have been line of best fit because they don't touch every single data point. Correlation is the relationship between variables, and a correlation coefficient is used to determine the strength of the relationship between the data. A number, usually represented with the variable r between -1 and 1, that indicates how accurately an equation represents the data being examined. -1 suggests a perfect linear negative correlation, 0 suggests no linear correlation, and 1 suggests a perfect positive linear correlation. If you don't have this information in your notes, you need it. Here's example 1. Use the data to report a bivariate data analysis. Examine the scatter plot, regression, and the correlation coefficient round to 2 decimal places. We'll work through this together. This orange line is our line of best fit. You can see it's not jigging and jagging between every data point. It's just, you know, if there was a straight line running through it, that's where it would be. So the scatter plot and the regression indicate that the association is positive. You can see that because it's increasing from left to right. Okay, the relationship is linear because the points closely resemble a straight line. The strength is strong because the points closely follow a straight line, and there are no outliers. We did all of that in the first part of the lesson. Now we're going to use GeoGebra to determine the correlation coefficient. Whole lesson on correlation coefficients, so I'll probably only show you how to do this once. If you need more help, leave a comment and I will make another video. So click Start Calculator. We have the information in table form, so click Table. We're going to enter all our x values, which are hours studying. So we have 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 5, 5, 5, 6, 6, 7, 7, 8. Let's come over and create our y values: 70, 65, 75, 78, 72, 85, 88, 78, 88, 85, 90, 94, 96, 97, 88, 91, 96, 95. Okay, that's going to create our data points, which we're going to have to zoom out a whole bunch to see. Okay, here's our lovely little line. Okay, so now what we need to do is we need to go here and we need to go regression, I believe. Let's see, which is going to give us our correlation coefficient right there, which is 0.87, and then 9, so probably like 0.88. So there we see 0.88. That's close to 1, so it indicates a strong positive relationship. How can you describe the relationship between the number of hours studying for an exam and the exam score? Well, because it's a positive relationship, the more hours you spend studying, the higher your score is going to go. Whapam! Here's example 2. The scatter plot and the regression analysis indicate that there is no association. The relationship is, oh, I think I have these backwards. I guess I didn't put in the first page on 2. Sorry. The relationship is nonlinear because the points do not resemble a straight line. The strength is strong because the points closely follow this weird line. They call it curved. There are no outliers, and because the graph is not linear, you will skip finding the correlation coefficient. You can't find it unless it's linear. Okay? When analyzing the graph, you will find the sales of this product increased when introduced into the market. Sales peaked at year 2 and then began to decline in sales. This is a normal product life cycle. A new product will increase in sales until the market is saturated and as substitute items are introduced. At this point, the sales begin declining. This reminded me of the Labubus, except I don't think they made it 2 years before they became not cool anymore. Check in. What are 3 ways to report a bivariate analysis? You can use scatter plots, you can use the regression, and you can use the correlation coefficient. Here's question 1. Use the data to report a bivariate data analysis. Examine the scatter plot, regression, and the correlation coefficient. Round to 2 decimal places. This is all you, so pause the video, figure it out, come back. Okay, the scatter plot and the regression indicate that the association is negative. If we put a line through here, you can see it's negative. It decreases as you move from left to right. The relationship is linear because you can put a straight line in there. Okay, the strength is strong because the points closely follow a straight line. There are no outliers. And then if you put it all into GeoGebra, this information, the correlation coefficient R is negative 0.98 when rounded to 2 decimal places, and this indicates a strong negative correlation. How would you describe the relationship between earned run average and the winning percentage? Sneezes. How would you describe this? I would say your average winning percentage decreases as your run average increases. Okay. Here's question 2. Use the data to report a bivariate data analysis. Examine the scatter plot, regression, and the correlation coefficient. Round to 2 decimal places. Pause the video and do that. Okay, you can also, if you just go straight to GeoGebra, you can just graph this, okay, which is what I would do. So here's your graph. The linear relationship increases as you move from left to right, so it's positive. The strength is strong because they closely follow that straight line. There are no outliers. And when you use the regression function, you find that the correlation coefficient R is 1.00 when rounded to 2 decimal places. This indicates a strong positive relationship. A correlation coefficient of 1.00 is a perfect positive correlation. A perfect correlation means that the variables move together in exactly the same direction. The line would cross through the middle of these perfectly. So how can you describe the relationship between the temperature outside and the number of cricket chirps? As it gets warmer, the crickets chirp more. Okay, end of the lesson. Practice question 4. Use the data to report a bivariate data analysis. The correlation coefficient is R equals 0.89. Determine whether the association is positive or negative and whether it is strong or weak. Okay, it's neither strong or negative because, it's neither positive nor negative because it's random. Okay, but they are forcing us to choose one. So if I had to choose, you can see they're going down. So we'll say weak negative because the scatter it's almost random. It's hard to even pick which direction it's going. So it's going to be a weak negative association right there. Practice question 5. Use the data to report a bivariate data analysis. The correlation coefficient is R equals 0.89. Which of the following statements must be true? Since R is close to 1, there is a strong positive linear association between the dollars spent and the number of gallons of gas obtained. So to find out if it's a positive or a negative, you can go ahead and graph this, or you can look at it and see if you can figure it out yourself. So 10, 11, 9, 13, it's not going to be a perfect positive or negative. You're going to have to graph it to find out if it's positive or negative. Since R is not close to 1, there is no association between the dollars spent and the number of gallons of gas obtained. Since R is close to 1, there is a weak positive linear association between the dollars spent and the number of gallons of gas obtained. Since R is close to -1, there is a strong negative linear association between the dollars spent and the number of gallons of gas obtained. 0.89 is considered close to 1. Okay, so you're going to want close to 1 as your answer. So is it a strong positive linear association or a weak positive linear association? It's going to be strong. Okay, quick check. Question 4. Use the data to report a bivariate data analysis. The correlation coefficient is R equals -0.95. Which of the following best reports the relationship between the number of absences and the final grade? If it will help you, go ahead and enter this and graph it, and then you can answer this, or you can just use this information to answer it. Use the data to report a bivariate data analysis. The correlation coefficient is R equals 1. Which of the following statements must be true? I don't know why that is there. I guess because I really want a boyfriend. So you can just use this information, or you can graph it to be able to figure out this answer. Okay? Thank you. Hopefully the brand strategy created will be the starting point for success.